Hi boys and girls, this is Mrs. Twisdale. I'm going to teach you lesson 1.4, which is greatest common factor. This is standard 6 number system 4, and we actually have two-part objective today. Of all of your lessons today, I would say this one is probably the most challenging, so I hope you're up for the challenge. You're going to do a great job. So your objective is, Felicity, are you helping me out here? I can find the greatest common factor of two whole numbers. And I can also use the distributive property to express a sum as multiples of a sum. So let's go ahead and jump right in. Sorry, Felicity's trying to help me out here. Okay, so we're going to start with factors. Now, we have been doing factors a lot this year already. So you'll be like, Mrs. Twisdale, we've done this. Good, that's good. Please remember that. We've already done this, so it doesn't stress you too much. So we're going to look at these factors. Factors are two whole numbers that can be multiplied to equal the main whole number. We've done factors with the T-chart before. There's a couple other ways as well. So the factors of 27 are 1 and 27. Now remember, if that's all you have, 1 and 27, then it's prime. But 27 also has 3 times 9. So altogether, 27 has, oh bless you. Bless you. That was a good sneeze. 27 has 4 factors altogether. It has 1, 3, 9, and 27. Okay? So let's put this with our greatest common factors, or GCF. Now that's the largest factor that's the same for both numbers. So, for example, and make sure you're pausing this and writing these down in your notes, or it's really just a waste of your time. So we just did 27's factors are 1, Felicity, 1 and 27, and 3 and 9. Okay? Now, I also have to do the factors for 18, which I have 1 and 18, 2, whoa, that was a funky looking 2, 2, and 9, and 3, and 6. So if I look at all of the common factors, they both have 1 as a common factor as well as 3. Well, 3 is the greater of the two, so our GCF for 27 and 18 is 3. Wow! Oh, Felicity, stop bouncing. It's just bouncing around. There we go. Now I can draw. Is 3. So I'm just going to show you another way that you can find the factors. So you can also do it as a list, like this. 1, 25, and 5. And then for 40, it would be like 1 and 40, 2 and 20, 4 and 10, 5 and 8. So you could do it as a list like that, and then you can just circle the greatest common factor. So that's another way that you could also find the greatest common factor if you want to do the T-chart or the list. And then I'm going to show you one other. You can also, oh, sorry, here's a try it, and then I'll show you another way. So go ahead and try finding the greatest common factor of 14 and 35, and then list it in your answer. Okay, so to find the greatest common factor of 14 and 35, I'm going to list the factors here. The factors for 14 are 1 and 14, 2 and 7, and that's it. For 35, we have 1 and 35, and not 2 because it's not even, and 5 and 7. And then our greatest common factor here is 7. That one I think was on your homework too, just to give you a little heads up. Felicity. Okay, here I'm going to show you the other way, which is prime factors. So think back to when we did prime factorization in lesson 1.2. And I want you to do the prime factors for 12. Remember, so 3 times 4, and then we break this down. 2 and 2. So our prime factorization is 3 times 2 times 2. And then if we do the prime factorization of 18, we do 3 and 6, and then 2 and 3. So we have 3 times 2 times 3. And then if you take the prime factors and you decide which ones they have in common, so they both have a 3. So I'm going to cross it out and put it in the middle. And they both have a 2. Cross out, put it in the middle. And then 12 has one other 2, and 18 has a 3. And then whichever numbers, here's where it gets a little tricky. These numbers in the middle, you're going to multiply them together. 3 times 2 equals 6. And so the greatest common factor of 12 and 18 is 6. So that's another way you can find the GCF, is to do the prime factorization and then multiply their common factors. I don't care which way you do it, whichever way, whether it's list or T-chart or prime factors, that is totally whatever works best for you. Okay, now the next thing I need to show you is the distributive property. So with the distributive property, you're going to have to know the factors so you can pull them out of numbers. So let me show you what it means. So the distributive property is when you're multiplying a sum by a number is the same, or let me tell you this again. It is the property that multiplying a sum by a number is the same as multiplying and then adding. So I think the best way is to show you an example. So if you have 5 times 8 plus 6. So normally what you could do is 8 plus 6 is 14, and then times 14 by 5. But the distributive property says, well, you know what? You could also look at this as 5 times 8 plus 5 times 6. And that means 5 times 8 is 40. Oops, let me grab the pen. Is 40, and 5 times 6 is 30. And that would equal 70. And if you wanted to double check, 5 times 14 is 70. So it is the same thing. Another way they would write it is 40 plus 30 is the same as 5, sorry, I'm down here now. 40 plus 30, and they factored out, they said, oh, the GCF of 40 and 30 is 5, so we'll put that on the outskirts, or on the outside, and then do 5 times 8 plus 6. So let me show you how you would solve a distributive property. Okay, so there's a couple of steps in the process. So the next few slides are going to use this same example up here, and then I'll just show you the different steps. So the example says, use greatest common factor in the distributive property to express 36 plus 27 as a product. Now a product is the answer of a multiplication problem. So first you're going to take 36 and 27 and decide what your greatest common factor is. So I'm going to use a T-chart for 36 and 27. We've done 27 a couple of times now. Okay, and 36 we've got 1, 36, 2 and 18, 3 and 12, 4 and 9. They have a lot of common factors. Look at this. 1, 3, and 9. But the greatest common would be 9. So our GCF is going to be 9 here. So once we find the greatest common factor, we're going to go to step 2. Step 2 is write each number as the product of the GCF and another factor. So what that means is I'm going to take 9, and I'm looking at 36. 9 times what equals 36? 9 times 4. Put those in parentheses. Plus 9 times what equals 27? 9 times 3. So I just took these numbers up here, 36 and 27. I took 36 and divided it by 9, and it gave me 4. I took 27, divided it by 9, and it gave me 3. So that's step 2. Remember, I got my 9 from my GCF. Step 3 is you write 36 plus 27 as a product. So that looks like this. It would be 9 times 4 plus 3. Okay, and I just want to show you again. This is what we had on the last slide, 9 times 4 plus 9 times 3. And so I just took both of these 9's here, and then my 4 and 3 are right there. Okay? And that is the distributive property. So I want you to try this one. Use greatest common factor and the distributive property to express 24 plus 30 as a product. Go ahead and try it. If you have questions, please feel free to ask me. Okay, so I want to take a look at 24 and 30, and I can do a t-chart, or actually I'm going to list the multiples this time, do it a little differently. 24, I've got 1, 24, 2 and 12, 3 and 8, 4 and 6. For 30, I had 1 and 30, 2 and 15, 3 and 10, and 5 and 6. So common, I have 1's, I've got 2's in common, 3's in common, and 6 in common. So 6 would be my GCF. Then I'm going to say, okay, 24, right here, divided by 6 would be 6 times 4. And then I'm going to also say 6 times, I'm looking at 30, 6 times 5 equals 30. And then I'm going to take that and I'm going to pull these 6's out to the side. 6 times, parentheses, 4 plus 5. And then I can easily solve that. 4 plus 5 is 9. 9 times 6 equals 54. Okay, so actually I boxed around 54, but your answer is really this, 6 times 4 plus 5. That's what we're looking for because it wanted us to express it as a product. 24 plus 30, though, just to check our work, is 54. So if you put 54, you're half right, but this is really what the step was that I was looking for, was this 6 times 4 plus 5. Okay, and that is actually all of our, I don't even have anything on this slide. That's our full lesson for today. So we will review this as a class because it is the trickiest of lessons. But if you have any other questions, please feel free to ask. And if not, I hope you have a great day of learning.